From Speech to Speech, a tale about Amazon Nova Sonic with Dominik Wosiński. Hey everybody, how's it going? Hello everyone. Hey Dominik, how are you doing tonight?
Hey, I'm doing great. How about you guys?
We are doing fantastic. Thank you so much for staying up super late your time to come to talk to us today about Amazon Nova. I've looked at Amazon Nova. I know a little bit about it, but I'm actually really jazzed to see. I know it's on Bedrock. I know it's speech to speech. I know it's agentic and it does multilingual. But the things that we're talking about previously, this looks like it's going to be a really fun show. But before we get into that, holy crap, is that Eric Wright I see on the show once again?
It's been a while. I just got, I'm lucky enough, thankfully, to be partnered up with Dom. And GTM Delta, we help with DevRel and marketing for the Halo Radius group. So thankfully, it's I get to pair along and I get the easy part of the job. I just get to watch all the talent do the real work, and I get to sit in here and just have the crazy mic.
It has been a long time since you've been on the show, Eric. It was easily since the before times, pre-COVID. It's been a hot minute since you've been on. The last time that we talked was so you and I both do the conference circuit a lot, and you've usually got your amazing on the road studio set up in some hotel close by, and you're like, hey Chris, come over here, I got a spot for you. and then we do a recording, and you always had this like amazing rig in a suite somewhere, and I'm like, I have camera envy from your setups.
Yeah, awesome. We're bringing it to the show floor, so we'll see. For anybody that's on here that's going to be at KubeCon, we're going to have some stuff going on as well, and I'll talk to you at another time, but we can share with all the vBrownBag audience. We're going to have some panels and podcast opportunities on site. So hopefully we'll find some great folks in amongst this crew, as well as folks in the audience.
Awesome. I'm sure that we'll be able to. Damien, what about you? How have you been?
I've been doing really well. I'm actually really happy to be on here with my old buddy Disco Posse. We've been to Vancouver together, Tokyo, Paris. We went to Paris that was my first time in Paris. Was that in Paris where you ate the raw hamburger meat with the egg?
Oh, quite. Top? Yeah. Well, you can insert city name here. I've eaten raw meat in that city. Yeah.
I actually have a lot of Eric Wright stories I tell my wife. I'm like, you've never met the guy, but here's a story about it, a place where we were together. So yeah.
Chris and I have shared a bit of raw meat ourselves in Paris, the restaurant, right?
we used to have a tradition. Eric's birthday coincided with was it reInvent or was it okay? So his birthday coincides with reInvent. I found that out. So for like 1 or 2 years, we went to Mon Ami Gabi on his birthday and did the raw meat offering that they had. Yeah. Good times. Dominik, welcome to the show. I apologize. We're sitting here gabbing on like old hens, and you're like, I just want to go to sleep, guys. Come on, come some slack here. What is happening?
No worries. You can't have too many raw meat stories.
Yeah. Tom, have you seen Eric eat something that kind of made you pause and say, "What the heck"?
No, I haven't.
Oh, okay.
He hasn't had that yet, but don't worry.
I haven't yet.
We are young. There are many opportunities ahead.
Yes, raw meat here in the United States is not really a thing that a lot of people eat, especially raw ground beef, right?
Correct.
And so, other countries that care more about health than capitalism, you can actually do that. So.
And in the States,
you can do it.
It's definitely finding unpasteurized meat or unpasteurized cheeses and raw meat is a little bit harder over here, isn't it?
Oh yes,
but they're so delicious. Okay, Dom, tell us a little bit about yourself. This is your first time on the show, and I don't even know what Halo Radius is. So how are you doing?
I'm doing great. You already spilled a little bit that I'm from Europe due to the time zone difference. I'm from Poland. I work with Halo Radius. I think Eric will share at the end a little bit more about the company, I think, so we can leave it till then. About myself, I'm a software engineer working with data, AI, and backend mostly. That's why the demos you're gonna see will have terrible front ends, because I never had a good hand to that. And yeah, that's pretty much about me, I think.
Cool. Okay. Well, with that, then why don't we segue into the actual presentation, because we definitely want to learn more about this. So let me go ahead and bring up. There we go. All right.
Cool.
Dom, the floor is yours.
Cool. Perfect. Okay. Great. So yeah, we're gonna talk a little bit about speech-to-speech in general, and we're gonna put it a little bit more into perspective of new unified models from Amazon, especially Amazon Novasonic, which is a speech-to-speech model that was released this year. So yeah, we can start with talking about, like, why do we even bother? Don't we already have those fancy LLMs developed over a couple of last years? Do we even need speech-to-speech? So one thing that we work a lot with is customer experience and customer support business. So there will be a lot of insights from this business, especially because we have that large experience there. So customer support was one of the early adopters of LLMs and generative AI for chatbots mostly, right? You can go, currently even the simplest, smallest online shops have some sort of a chatbot. And I pretty much guarantee you that if you try to type something in there, it's going to be passed to a LLM of some sorts with some automated response saying that, yeah, we are processing the response and you're going to get answers shortly, but 99% of the time it's going to get passed to the chatbot with maybe some sort of a knowledge base with a RAG behind the scenes, but it's just going to be automated like that. And it works from one perspective because it allows smaller businesses to extend the capabilities of their customer support. Obviously, like, you want to have, like, no small shop will be able to hire people to work at 2 a.m. or in the morning. Well, 2 a.m. in the morning always in any kind of business. It just doesn't work. So it from one perspective, it does work for the customers. But actually, the research done by Harvard Business School shows that it's not exactly the answer, because according to the research, 77% of people are actually frustrated with the chatbots because they aren't, like, depending on how they are written, they aren't that good, if you think about this. And 88% of the people actually prefer to talk with the real person, right? That's what the research says. If you think about this, there is a like technology versus biology thing here, right? So the technology has been developed much quicker than biology. Obviously, we evolved over thousands of years into what we are today, and that LLMs and chatbots were developed in 10 years or so. So we have a technology where we can communicate properly with the computers, but the human biology still remained the same. We were raised in the world where we prefer to talk with the people. We were raised into speech being our main communication medium. So that's one of the reasons why chatbots may not be the answer in the customer experience, and in many more businesses too. So that's one of the reasons why speech to speech may actually solve the problems we are talking about, which is making models feel human-like, generate human-like voice, can actually make the the customers feel better, because they would prefer to talk with a real human. But if the machine will be good enough, they most probably won't know this. We can show in a few moments how well how good models are now and what was the development that has happened in the past 10 years. I will show this on examples, but yeah, so that's one of the things, is that we probably need something else than chatbots in order to support other businesses. The other thing is that the problem with speech-to-speech is that for a long time, the latency is a big problem, right? So if I try to talk with you, you expect me to talk normally, right? We all have some sort of message. We are used to some sort of message-based communication, right? Either it's Messenger, WhatsApp, Signal, or whoever uses. And we are used to the fact that when we write something, we may not get a response immediately, right? So this is the same thing happens with the standard chatbots, right? You send a response. If the delay between you getting a response, sending a message and getting a response is 5 or 10 seconds, you are probably fine. The problem for speech is that it doesn't really work, right? Even 3 seconds of delay in a conversation mean I talk like that, which is not normal, and you don't accept that. So for a very long time, the problem was that the speech was, we just didn't have good enough technology to create that, because there is no point in creating an agent that is able to talk if it's like a sentence every 10 seconds. No one is going to use that. That's why this is something that is appearing right now as a use case, because new developments in technology and in the models brought us to the world where the loops of 500 milliseconds or less with the unified models are possible. So on the demos, we're gonna show that if you try to talk with new models, Nova Sonic, GPT real-time, the delay is almost human-like. It's depending, of course, on your internet connection, but if it's set up properly, it's not going to be different than just talking between you and someone else. So why we are talking about this right now, simply because this is something that is becoming possible through technological and research development that has been done. So at the moment, also, if you think about this, if you read any kinds, Damian, you said you read Reddit, right? I think if you read anything at the moment, you've probably seen the word agentic or going agentic, becoming agentic, written multiple times in various contexts. And the whole world is currently talking about going agentic. And I believe, and we believe, that this is just a next step. So currently we are working on the agents, and by we, I mean pretty much everyone. Agents that are text-based, agents that can automate stuff, agents that can do things for the companies, in the customer support or other business. But the next step will be just agents that are driven by voice fully. So they can handle tasks end to end. Customer can call in to customer support, and there can be an agent that is voice driven and can handle everything from beginning till the end. They can track orders, cancel orders, make new orders, change your password, email, everything, which is a natural development, right? Once the speech-to-speech models will become good enough, once the agentic frameworks will become good enough, the connection between them seems really natural. So that's what is going to happen. And new models are also much better because they are generating human voice that is much more human-like. So they are much better in detecting intent and sentiment. But also, what is very important is that they are actually generating a voice that sounds like a human voice. So what I mean by that is that if you think about this from the perspective of development, it's always hard to pinpoint or understand how something has developed over time if you look from the perspective of a single point in time, right? Like if you look at the world today, you see smartphones, but it's only if you start thinking about the fact that 20 years ago or 30 years ago, people didn't even have mobile phones, then you start to understand how big the development has happened. And same goes for speech-to-speech models. So I've created a sample. We can, in order to understand that, we can try to see how Jennifer, which is an artificial voice, has changed over last 10, 12 years, right? So let me just make sure.
It's funny, just while Dom's getting that set up, remember that the old way that we used to get people to stay engaged with voice agents and with like IVR systems, they got to the point where they would do the thing where it would do a voice and they would say, "Oh, let me help you with that." And it would put in a fake like typing noise, which so while it was waiting, it made you think that, oh, there must still be somebody there, but it's just off in, round trip transaction land, lost. But they had to hint that there was a reason to stay, because otherwise you would hear the dead air and you would immediately just tap out. Exactly. Dom's entirely fabricated through AI.
Yeah. Yeah.
So there have been a couple of questions that have come in from the audience, and I don't want to take away from the demo, but you did say that when agentic becomes good enough, you were talking about good enough, and the listener wanted to know, what is your bar for good enough? At what point do you think agentic AI is going to be ready to take over voice command? Like what is the thing that's going to make it go, yes, now we're ready?
Yeah, I mean, from my perspective, it always depends on the specific business applications. We can create voice-based agents right now. It always depends on what you want to achieve and whether the agents that we have right now, whether the models that we have right now are actually something that can fulfill your business needs. So I don't want to set any specific bar. It's pretty much up to whoever is going to try to implement that. For some use cases, I believe it is possible right now. Like you can create a simple agent that will do stuff for you based on voice. Like, you can do it definitely 100% today. Whether you can do it for business critical things, it may not. That may not be possible. Also because the voice-based models are a little bit less developed than the LLMs themselves, which makes it a little bit harder.
Yeah, because I was thinking of it myself. So my bar for turn the house lights on is extremely low versus sell all of the shares in my 401k, which is significantly higher. So, okay,
exactly.
Thanks. I didn't want to take away from it. I think
no worries.
You can test, because you could say Xbox turn off, and then we'll see how many people have speakers on their be careful about what may happen when people do voice commands.
Alexa, sell all the shares and let
That's right.
buy all the Bitcoin, and then
That's why I use Siri, because she's an idiot.
Yeah. It's always good to go with the last place AI model, because then, they won't be moving too quick.
I think last place is being nice for Siri. Anyways, so how has Jennifer changed?
Cool. Yeah. So what I was going to show is Jennifer is basically an artificial voice. The first sample is like that. It was generated around 10 years ago. It was actually generated with the almost top of the top technology at the time, which was a Polish company called Ivona, and it was very popular. I'm not sure if you've ever done this, but I come from the times where when I was in school, kids were doing a lot of voiceover videos with those voice synthesizers, and so this robotic voice is very heartwarming for me. But yeah, it sounds like that.
Hello, my name is Jennifer. Would you believe if I told you my voice is not human? It's true. Enter any text and press play.
I'm not sure about you, but I kind of would believe that, and it's not something that I don't know, dug out of the darkness. This is something, that's how the voice generation technology looked like long time ago. It's not even speech to speech, right? This is a pure text to speech based technology, because at the time there wasn't the speech to speech that was available. So I've generated a sample today using one of the models available on the internet, and that's how Jennifer has changed.
Hello, my name is Jennifer. Would you believe that my voice is not human? It's true. Enter any text and press play.
As you can see, the change is quite significant if it comes especially to the fact that the first one was basically a robot-like voice with no emotions and weird stops in weird places. So that's pretty much how it looked like 10 years ago. So if someone asks why now, why we didn't try this before, why speech to speech was not that popular, pretty much because of that. Like if you like trying to converse with that wouldn't be very good for humans. Like it's not very like good UX.
It's funny that at the time it was such a big thing, though, like, because like you said, it was basically a speak and spell, but we grew up on that tech. Like we, pull the thing, the cow goes moo, and like it was a groundbreaking. Like that first Jennifer that you played probably would have gotten a standing ovation at the Moscone Center. And then all of a sudden we're like, why would you use this? This is garbage. But it's like we've moved the window of acceptable on the high end and also on the low end, that we would never think that this is worth even looking at now. Yet it used to be the top end.
Yeah,
exactly. And we could play a little bit more with that, but we can also get it angry.
Oh, just stop it already. We have a lot of things to talk about.
So we have a few things to talk about, but you can also see how well I've asked it to be angry, and well, it was, as much as the computer can get angry. But the voice generation technology at the moment, which is like a pinnacle, and it's a pinnacle of technology, and it is one of the most important things in speech-to-speech systems. This is at the moment as good as it ever was, and it's getting better. That's why it's enabling us to even talk about stuff like voice-based agents or voice-based customer support. Cool. So that's what speech is in general. That was a short introduction to what speech is. Now we can try to see why speech is hard from perspective of computer, of course. For us, it's super easy, right? I'm talking to you, you're talking to me. As long as we are in the same language department, we understand each other and it's perfect. There is no problems whatsoever, right? So the problem is that the computers were never meant to understand that. Like all those funny words and sounds we have, the computers were never developed to understand that. right? The text-based communication is simple. This is just text turned into bytes and it's sent. It's perfect. For the voice, it's a little bit different, right? So the speech is hard for the computers in speech-to-speech systems for a couple of reasons, actually. One of them is actually in the name. It's speech, right? So it requires many more steps for a computer to correctly understand what we want, especially that if you look at what we have at the moment, the generative AI is mostly all the agents and all the systems are built on the large language models that are text-based. They aren't speech-based. They were trained on text. They were trained to produce and accept text. So that's why if you look at the speech-to-speech system application, it is something like that. Something like this diagram. So it is a system that accepts user voice, simple, and produces model audio response, also simple. So what happens inside of the system? Well, usually there are a couple of steps that are happening. The simplest example is this. It wouldn't be the best model. There are a couple of steps that I've omitted for simplicity that I'm going to discuss in a second. But what happens is that you have speech-to-text model, which is essentially a transcription of what you have said into a text transcript. Now, this is simple. Then another step is LLM, which allows us to use already existing functionality, already existing technology. So all kinds of chat or GPT models or kinds of Gemini, Claude models could be injected there to transform the user request and produce the response, right? It can be like RAG under the hood with some sort of knowledge base or anything like that, but it will be powered by a large language model. And when the large language model produces some sort of an output, it is transformed from text to speech, and then we produce model audio response. So this is like the simplest representation we could come up with. Now, the speech is very hard for a couple of reasons. So first thing is that generating speech is very hard. I think there's it's not famous quote, but there's a quote by Jensen Huang from NVIDIA CEO, who is NVIDIA CEO, who said that speech to text is just a technology, but text to speech is actually an art, because it actually requires, it is sort of an art form to produce a human-like voice just from the text and to properly mimic the emotions, right? So one thing that we've kind of briefly touched on is the generation of the speech itself. However, there are two more things or a couple of other things that are really hard compared to the text-based communication. One thing is that when you are writing, you are either sending something or not, right? Like if you send something to a chat, LLM, or agent, you either send something or not. If you send an empty message, it's as simple as just checking whether this is an empty space, right? If this is a white space or white space characters. If you do that, then you know that user has something and you should react to that. With speech-to-speech systems, it's a little bit harder because you don't actually, you can turn on your microphone, we're gonna show it on the demo, and you can be silent. So like the model shouldn't react to that because it's just white noise. But detecting white noise is much harder than just detecting whether the text is there or not. So usually in the speech-to-speech systems, there is another component which is called voice activity detector. It's a separate component that actually detects whether the model should react at all or not, because maybe we can just ignore it until user actually says something useful. And another thing that is quite tricky and quite problematic compared to this text communication is the turn detection, right? So when we are talking about text, when you send something, we assume you've ended your turn, right? If you go to any kind of chatbot at the moment, any kind of ChatGPT or Gemini or anything else, if you send a message, it basically assumes, okay, your turn is done, you expect my response. Well, it's not so easy with the speech-to-speech, right? I've been talking for quite long, maybe too long already, but technically, you know that my turn hasn't ended yet, right? You know that, like, we humans easily understand that someone has asked a question, someone expects a response, but it's because we were born and kind of raised and trained to do that. For machines, it's much harder. That's why there is additional complexity which involves detection of the turns, which usually happens after speech to text transformation. So the transcript is actually passed into the turn detector, and we detect whether we should actually send something back, or maybe user is still talking and let him finish. We should not barge in. The model should never barge in into user turn. We should wait. So this is like, it looks easy on the diagram, obviously just a couple of squares, but those are all very complex machine learning models under the hood, right? LLMs, we know those are huge models themselves, but we have at least 2 or 3 another very complex pieces of technological and scientific developments that are required there in order to make the speech-to-speach system possible. That's why the speech is hard. Speech requires a lot of steps, and it is a really complex thing to build in order to make it possible. That's why it's currently overall really hard to build such a system, maintain it, and make it usable. This representation is this is one way to build speech-to-speech systems, which is, you can technically do it. You can technically get every part separately. You can get separate STT, separate LLM, separate TTS, just connect them via something, and you're going to have your own system. However, what is currently also happening on the market is that there are models that are being developed that are just all of those things combined together. And one of those is actually Nova. Another thing is OpenAI GPT real-time, that are actually, they combine all of those things together. So you just send a user voice input, you get a response, but you don't care what's inside. This has both pros and cons that we can discuss in a second after we go to the next slides. So when it comes to the state of the speech-to-speech this year, we've added 2025. So if someone sees that in 2027, they don't record this presentation and they don't use it just the way I've used Jennifer voice, and they don't point and say, look what they said, it doesn't make sense anymore. But yeah, so when it comes to state of speech to speech in 2025, it's being like actively developed. This is all of that is relatively new. Those true speech to speech models, which is Amazon Nova Sonic and GPT real time, those are quite new. So Sonic was released in April this year, if I recall correctly. GPT Real-Time was released 2 or 3 months ago. So those are things that are brand new, they are fresh. They come with all the features integrated, right? You have like intent detection, you have budging detection, you have whole reasoning models, turn detection, sentiment, detection of voice activity, transcript generation. So you just have sort of a framework. Think about Spring. I'm not sure if you come from the Java world. I do, and I still have nightmares of Spring. But basically,
that's how you can tell you come from Java world.
Yeah, exactly.
PTSD.
Exactly like that. So yeah, if you think about this, it's sort of like a programming framework. You have something that is developed, you can tune it to some extent. You have those bolts that you can touch and try to configure it, but it's just so much you can do. At some point, it's just, it's one system. So if you want to do something custom, most probably you won't be able to do that. But it comes with benefits, obviously, because it's much easier to use, it's quicker to set up, and it's very good for POCs, for example, that we're going to discuss also. We also have things that are more sort of building blocks for what I've shown on the previous slide. So we have open frameworks like Pipecut, LiveKit, VO Code that allow you to basically just compose your own parts to a whole pipeline, right? So you can select, well, I want to use this LLM, I don't know, I want to use Gemini, and then I want to use the voice activity detector that I've created because for some reason. And then the turn detection, I want to use this. And then for speech to text, I want to this. For text to speech, I want to use this. And then it creates your own platform, which is much more configurable, of course. But it comes with the fact that you actually need to be able to understand what you're doing. Configuration is much easier. Another good thing is that you can go fully open source, right? There are open source models for every part I've talked about. So you can use open source models for everything. And with those frameworks, like, you can stay fully open source. You can deploy everything on premise. I assume in future, in a couple of years, maybe even 2 years or something, with the smaller models, you would most probably be also able to deploy everything on edge, a very simple speech-to-speech model. So that is very good. You can optimize whatever you want, but you need to understand what you are doing, and the maintenance of that is much harder. So this is something to consider. Also, at the end, we're also gonna briefly touch on what the enterprise actually prefers and why. But when it comes to the state of the speech-to-speech currently, the trend is that latency is falling constantly for the past years, for the past months even. We can see that the latency is being decreased, and this is very important because, as we've said before, and as we are going to say in a slide or 2 slides, latency is one of the most important things when it comes to speech-to-speech generation and voice-based agents also. So the new models have multimodal support. They support both text and voice images. We are going to show that currently the Nova Sonic actually also generates transcripts real time. So all of that is really good. One new thing that is also actually introduced maybe in the last year is the improved interruption handling. So previously, if you had models, you kind of needed to wait until they finished talking, right? You asked something and they were talking, and they simply ignored what you said. now we can see, and we're going to show that it's like the barging and interruption is much more flexible, and it's much more fluent. So we are actually going to be able to just interrupt the model if it starts talking too much and we just don't want it to finish. We just interrupt. But yeah, so when it comes to what we have at the moment, we have pretty much two ways we can try to attack or approach the topic. We can either go with the closed systems or try to build something with the open frameworks. The results in the end will be more or less similar as in terms of the capability. But yeah, at the end of the presentation, I'm going also to briefly touch on what enterprise market actually prefers at the moment. Cool. So we've talked a lot about speech-to-speech in general, so it's time to close the circle a little bit and start talking a little bit about what is in the title, which is Amazon Novasonic. So yeah, Amazon Novasonic Amazon has released a Nova family of foundational models. There is bunch of text-based. Those are actually multimodal models, primary text-based. One of those are 3 or 4 models, but there is one more model, which is Amazon Novasonic, which is a full speech-to-speech unified model. By unified, I mean that this is what I said. It has everything embedded internally. You can't really tweak how they do voice activity detection or how they do turn detection. It just works, and you have to accept it or not, but it works more often than it doesn't. It offers a bidirectional streaming, which has a very good effect on the latency. So it's really good in this sense. The automatic turn detection and verging support, it works really well. We've tested it on a couple of use cases in POCs for multiple use cases, and it worked really well so far. It supports multiple languages. I think there are 5 languages it currently supports, but it does not support translation, which means you can talk with any language you pick, but it has to be one language. So you can't ask it to translate from English to German. As Eric said, that would be too good, and we would solve all the problems of the world. So it's still something that we need to have to work on. But yeah, so this is something that is available. This is a model with simple API. The API is relatively okay. It's definitely very simple. It currently supports most of the languages. The SDK currently supports most of the languages, which is Java, Python, Node.js, C# and a couple of others. So pretty much if you can program, there is a big chance you can use it with the available SDK. The simplest setup is around 200 lines of Python code. Just the simplest setup, I mean, just set up the streaming and provide simple system prompt to tell it what to do. And then you can start conversation. It's roughly around 250 lines of code, which is not too much if you consider that large part of that is just definition of JSONs that are going to be sent. So it's not very complex to start working with that. It automatically provides transcription for the generated and accepted speech. So this is also very useful for regulated markets, for example, or for keeping the history of the conversation. Right? You don't really need to do anything else. You can just get it straight from the Sonic because it generates it out of the box. What is really good about that is that it's an AWS system, which means AWS is currently investing quite heavily in AI via Bedrock family. There are a couple of services in the Bedrock family. The main ones are worth knowing is the Agent Core, which is a platform to build agents, obviously, as the name suggests, plus Bedrock knowledge bases, which is a platform to build semi-automated knowledge bases for research, augmented generation use cases. So those are two things that Sonic can integrate with. The integration isn't direct in a sense that this doesn't happen through the SDK. It actually requires some additional work, which is not perfect. One could expect better. I would probably expect better. I would want to have a direct integration through some sort of SDK with Bedrock agents and Bedrock knowledge bases. Currently, you can use them via tools, which is just API-based usage, which is okay because you can do it, but you can expect better from AWS building the model. Maybe in future it will come there. We have to wait and see. As I've said, the model itself is quite new, so let's see how it's going to develop. Another thing that is really good is the full observability coming from AWS, which is you have CloudWatch logs, Event Bridge, IAM for granular control, which means enterprise setup is super easy, just as good as with any other cloud service. You don't need to worry about API keys, about making sure that proper services have access to proper things. All of that can be managed through IAM and through CloudWatch. So that's a very good thing. This is very useful, especially in setting demos and POCs. If you want to have a couple of agents, for example, and they all should have access to the correct knowledge bases, with Sonic, it all works very well. So that's definitely something that is useful. One thing that is missing, sort of, AWS currently has a system called AWS Bedrock Guardrails, which allows you to define safeguards for LLM-based models. So you can define topics that should not be touched. Of course, you can define topics that, like filtering not safe for work, and either images or text. So just the classic guardrailing functionality. The problem with that is that at the moment, this guardrail is the AWS Bedrock guardrails. It's a multimodal, which is they support text and image, but they don't support voice, which means it makes it impossible to use directly with Nova Sonic. You would have to do it on the transcript, but this makes it a little bit harder, and we're gonna touch on this a little bit later, why it's harder. But yeah, so this is something that I would wish for, because that actually is something that is required. If you would like to build a fully fledged enterprise system, it actually needs to have proper guardrails. So the fact that it's missing, it's kind of sad and it's kind of tricky.
Well, I guess based on that, what we can probably do, I know in the interest, as we're with a 10-minute, I think I would love to see you jump to the stuff that doesn't work. There are lessons, like, because I know we were going to talk about sort of token use. What you mentioned, I think, though, about like what are the challenges? I would love to dive in here, knowing again from what I've seen, the people like, well, no one likes IAM, but they like that it's IAM ready. It's like no one likes JSON. It's just at least everything speaks the same awful configuration language. I'm pro HCL though, just FYI. So you can take
good
that
answer
to the team. So
nice.
We can also talk money, which is also an interesting thing, because if you think about we are in a modern world now. We don't speak words, we all speak tokens. So we all need to know what the token is, right? It's even for a simple text-based LLMs, right? It's not exactly defined. I think the rule of thumb that I found is that the token is roughly 4 characters or 75% of the word. That's what the definition I found is, I think, from OpenAI. So that's easy for the words. But what does it mean that the tokens are actually used in the voice-based communication? So it turns out that there were some tests done, and first of all, the tokens are actually tied to the length of the recording, and depending on the model, depending on the technology, the rule of thumb is that 1 second of the recording is between 25 up to 32, 33 tokens. So it ends up being 1 minute ends up usually being around 1,900 tokens. What is important, what is interesting is that I've seen some people doing tests, and it turned out that it may be surprising or not if you think about this, but it turned out that the actual format of the recording did not matter much here, which means it doesn't really matter if it's MP3 or something else. What matters is how long it is, because that's how much information you fill in here. So that's what's interesting. And yeah, the pricing is here. I mean, it's relatively okay. It's not very big if you think about this. So there are two pricings here, as you can see, speech and text. This is primarily because while the model inputs and outputs speech, it actually still thinks in text largely, which means text is used, for example, for tool execution or agent execution. So all of that is text based. So it's not like it actually under the hood thinks purely in speech. If you try to use tools, it's going to pass you the name of the tool in text, for example. So there are two prices that you have to account for. It is relatively okay compared to alternatives on the market, but everyone has to assess for themselves. It is totally okay. If you look at that, it's like 1 minute of recording is still way less than $1. So you should be fine to play around with that on the budget even. Cool. So that's that. And then, okay. So as I mentioned, so this is how this looks. As I mentioned, we've briefly touched this in the beginning, but we've done a couple of projects for clients, including a couple of POCs for various businesses. A lot of them were for customer support and customer experience, which means we have a couple of lessons that we've learned for speech-to-speech models in general, and building those models and building those systems that we would like to share before we dive deeply, before we show the demo and how all of that works. And we can discuss this a little bit after we finish. So those, as I mentioned, customer support is our main thing, which means some of those lessons are more specific to one market or the other, but I think they will be also, they can also apply to other markets too. So especially one thing that we've also mentioned is that latency is the new UX when it comes to building the speech-based systems, right? Latency can break everything. If there is a significant latency, it basically means your system is not going to be usable, right? Imagine calling someone the phone. If they don't answer in the if someone picks up the phone and they don't answer in 5 seconds, you're gonna disconnect immediately. That's what's going to happen, and that's how that's universal thing, and it will always happen. So latency, budget, and jitter handling, this is the most important thing in the building speech-to-speech systems, and it needs to be handled properly. Otherwise, your users will simply drop. They will simply disconnect, ignore you, and it will cause frustration, and your system basically won't be used at all, and they will prefer anything else. Just like everyone will prefer even chatbot, I can guarantee you, compared to a slow speech system where they have to wait 10 seconds for a response. No one will use that, because like the main problem is that you don't know whether there was an error and the chatbot is just burning, or is it just still thinking. So you don't have this, I'm still thinking. Maybe there should be some sort of a music, like I'm still thinking.
Well, maybe, I guess, given that we've got just a couple of minutes left, do you want to jump right in? Let's see what the demo looks like, and
yes,
and then we get to test the waters on it. And while Dom's getting that set up, another neat thing that we caught as a lesson today, that in talking with one of the other folks inside Halo Radius, and I never thought about this. I'm not a smart gentleman though. But we talked about the idea of like accelerating speech. So stuff like doing transcriptions and recording, they can actually run voice through like recorded stuff at like 2 times. And that actually cuts down, like it's able to understand it even though it's compressed in delivery. And I was like,
oh,
it
really?
never dawned on me that, like, because how do you can't compress audio or video, but it was neat that
you can speed it up.
You can speed it up, and it will still consume it with a relative like word error rate. I think that Omer was saying about like 10%, which is like the upper bound of range. But that was a trade-off of pre-processing. We can make it move faster. Different, of course. We're talking about speech to speech. So Dom's got an actual like we're going to talk to a real machine. So I'll let you get to the good stuff here.
Yeah, cool, perfect. I will switch my screen share because it's going to be a separate screen now.
This is the ultimate in demo test. We're going to try speech to speech while connected to a system that is listening.
So, all right. Has there been real quick? Has there been a study on from a human psychology perspective, the acceptance, like what is humanly acceptable for latency before somebody says, screw this, I'm out? Like, is it 300 milliseconds? Is it, I mean, because if there's like a little bit of a delay on a phone line for me, I'm like, I'll call you back. I hang up and I call them back like pretty much immediately. So what's that magic? Is there a magic number? Has there been a study for that?
I think, I don't know. For me, it's like for a phone conversation, it's a second. For my mother, it's probably like 5 minutes.
For mom, I suck it up.
That's the quote of the day right there. There we go. That's
a good answer.
That one's going to make the YouTube shorts.
Nice.
Yeah, I know. At least as far as like visual, Chris, the one thing we do know, like video and audio, it's 10 milliseconds. And if you deviate the video away from the audio by, usually it's even 8 is where it's wildly detectable. And at that point, you can't watch the person speak anymore because their mouth confuses your ears because you're watching the movement. Yeah, it's really, but it would be good. Actually, we will dig in, and there's got to be some standard out there on what the straight like speech to speech flow is.
It will be, some sort of, people will have, it's a frustrating study. So it needs to be done with care. So I've set up a couple of demos we can try to see. So the first one is actually a very simple Novasonic model. It's a couple hundred lines of code. It's done in Node.js in order to be able to present it. It has nothing. It's just basically a simple tool that allows, it's defined to be a tribal agent. So if I start talking to that, hello.
Hi there. I'm thrilled to help you plan your next adventure. Whether you're dreaming of a serene beach getaway, a bustling city break, or an adventurous trek, I'm here to make your travel ideal dreams come true. What kind of trip are you envisioning? Any specific? Oh, I see you're excited. That's fantastic. Let's dive into the details and
let's stop.
No worries at all. If you ever change your mind or want to explore more options, I'm here to help. Safe travels and have an amazing time wherever your journey takes you.
I'd like to
my
go
goodness.
to Thailand.
Thailand is an incredible choice with its stunning beaches.
Actually, stop. What's the time currently in Madrid?
I'm sorry, but I can't provide real-time information. However, you can easily check the current time in Madrid by using a world clock feature on your phone or a quick online search. If you need
Yeah, so as you can see, this is like a very, very big tool you can use. And setting this up took like literally nothing. You can also see that it just like I was able to not barge in normally and interrupt it, and it was following the flow. The voice was almost human-like, and it was emotional enough. You can also see that I've asked for information that it's not able to correctly provide because it doesn't have access to the tools. So let me switch the model. I won't switch the screen. I will switch the model under.
That model needs to learn to like chill out a little bit.
Yeah, it's like a zoomer. It's just like, oh, that's awesome.
Yeah.
Thailand's amazing this time of year.
Yeah,
try it.
It definitely is. It's the same thing as working with LLMs, right? It's overly. I think it may also be my system prompt, because the system prompt, I think I might have told it to be very polite and helpful. So maybe it's a little.
You're absolutely right.
Please reduce enthusiasm by 32%.
Yeah.
Yeah, that's something we're gonna need in future. But yeah, I've switched the model, and we can try to do something different. So we can. Hey, what's the time currently in Madrid?
Hey there. The current time in Madrid is 2:33 a.m. on Thursday, October 30th, 2025. Have a great day.
Cool. And what's the weather in California?
Could you please provide me with the specific city or town in California you're interested in? That way, I can give you the most accurate weather information.
Let's go with San Diego.
The current weather in San Diego, California is quite pleasant. It's 22.5 degrees Celsius, with a gentle breeze of 3.4 kilometers per hour coming from the southwest at 238 degrees. It's currently nighttime, and there's no precipitation expected.
Yeah, so now you can see it would be as the system prompt was exactly the same. I haven't changed anything. It would be exactly as polite as the previous Zoomer one. The only thing that we actually changed here is that we provided it with the tools. And what's important, those tools are not hard-coded, which means I've just provided it with the tools to be able to generate time based on the time zone, and check the AccuWeather based on that. And actually, this is also quite neat. It's actually checking the weather based on the AccuWeather lat and longitude API, which means when I asked it what's the weather in San Diego, it was actually under the hood. It calculated automatically what's the lat and long, and it asked the AccuWeather API. And I didn't really need to do anything there. It's just like bunch of JSONs you need to provide, and it's automatically able to do stuff like that. It's not like super sophisticated if you think about this, but then if you think about this, it's kind of interesting to do that, because it is pretty much like LLM packed in the with the voice. So it's quite neat what it can do at the moment, and it's all still new. So in a couple of years, 2-3 years, you can see how the chat models have developed, right? Like 4 or 5. I'm not sure when the first GPT was created, 4 or 5 years ago, and what they do right now. So in like 2-3 years, we can probably see that those models will get as good as the text-based models are currently. And yeah, so that's what we're gonna get. There is a couple of other things we can chat about, but I'm not sure if we have time.
We are getting a little bit long for the episode. There was one other question from the audience though that I wanted to have answered, just because this is a really interesting time and space for this kind of technology. So in your speech to text model, in your speech to speech model, you broke it down into speech to text, LLM, text to speech. In the consideration of the LLM slice of the model of that, is there a particular type of consideration for the LLM type, or are you looking for something specifically from the LLM, not like RAG injection of specific data, but like are certain LLMs tuned better for this kind of work?
So that if we are talking about speech to speech in a sense that we have separate blocks, you can do whatever fits your needs, because essentially when it's split, at the moment when it gets information, it is not much different from the actual chatbots or text communication. It was already converted. So as long as this speech to text model does good job, it shouldn't matter that much. I have a demo, or I can show you a simple code, or we can just discuss it. But the simplest demo I have is, I think, let me check it on the side. I think it's GPT-4.1 mini. I was able to set it up with GPT-4.1 mini, and it's working relatively okay with that. I think, yeah. So it's pretty much up to you. What do you want to use? The good thing about that, if you start playing with that in this way, which is like start splitting them, you can actually, some models are much better for some things, right? In here, we're using Novasonic, using GPT real time. We have no control. They are as good as they were created. But if there is a better model, like imagine someone develops a perfect model for handling, I don't know, something, customer support or code generation, you won't be able to use it, right? In using LiveKit or Pipecast, you can just inject let's use Claude, for this let's use Gemini, and you can use it like that. So it's pretty much up to you.
Okay, cool. Thanks. Yeah, that was it from the audience question perspective. Hold on, let me change this up so that we're all there. We go, nice and friendly again. Hey, everybody.
Hello
again. Awesome.
Hey,
Dom,
hey.
Thank you so much for coming on. This is. I'd love to have you on again, because this is something that's going to be evolving as, like, literally tomorrow there's going to be new stuff coming out from this perspective, and there's going to be more interesting things, especially after the announcements at reInvent and all of the stuff that's coming out about the new models. So super excited. Thank you for this, and I definitely want to get you back on again next year.
Thank you. I hope we can do it earlier though.
Yeah,
yes,
we'll ask it what the local time zone is in Poland next time before you let me schedule.
Yeah, I can set up that.
I was going to say, yeah, next time we're definitely going to be doing it in a time zone or a time that's more amenable to you, Dom. So awesome.
Yep.
All right, you get to sleep, and everybody else, thank you so much, and we will see you again next time. Bye.
Thanks, y'all.
Thanks a lot. Bye. Cheers.